Okay, so now we're going to move on to the angle side property, which is very similar to angle side angle. It just says that if we know angle, and a side, and we know that those are congruent to another pair of angles and another side, then the whole triangles must be congruent. Okay, so the congruence of two angles and a non-included side, so this is not the included side, right? It's not between the angles, it's a non-included side, is also sufficient to prove two triangles congruent. This congruence relationship is a theorem because it can be proved using the third angles theorem. Okay, so in words, if two angles and the non-included side of one triangle are congruent to the corresponding two angles and non-included side of a second triangle, then the two triangles are congruent. For example, if angle A matches angle D, so 2 marks here, 2 marks here, angle B and angle E are congruent, and length BC and length EF, so EF and BC, marked with one line each, are congruent, then we know that the whole triangle is congruent. So there's a proof that they go through here, which you can take a moment to read if you'd like. However, I'm going to go through a different way to show why it's true other than to go through these kind of logical statements to prove it. The way that I'm going to show it is just kind of back with what I started with over here. So this one says two angles and a non-included side are enough to know what triangle we're talking about. Okay, well, that makes sense to me because remember, as soon as we have two angles, we know the third angle. Okay, two angles is enough to know all three angles. Okay, one angle is not enough. We could have different triangles that had this corner. But if you have two angles, you automatically know the third one. Okay, so basically in this picture, they're saying that we know the two angles and we don't know the included side. We don't know how long or short it is between those two, but we know a different side. Okay, so we know a non-included side. Well, if I know that non-included side, if I know the length of that non-included side, then I basically do know angle side angle already because, right, these were the two angles. We didn't know the included side, but knowing these two angles gave us that angle. So if we're calling, this length right here our non-included side that we've been given, just like in the picture, the non-included side is the one that's not between the two angles that are given. If we are given that length and we automatically already knew this angle because we knew two of them to begin with, then we now have an angle side angle relationship. Again, we've just worked our way back to having ASA. So an angle, an included side, and another angle. Okay, so say that one last time, try to make sure it sticks. Even though in this picture they've given us two angles and a side that's not in between them, since we know these two angles, we automatically know what angle C has to be. It's whatever adds up to 180 after you add these two. So knowing these two angles gives us this angle. Therefore, we do have an angle included side and an angle. And we can use the same property as we went through in the last discussion to say that they must be congruent. So to say it again, ASA and AAS. So as long as you have two angles and a side, it actually doesn't matter which side it is. You can show using any side you want that having a trio of features and two angles and one side is enough to tell you what the triangle is you're talking about. Okay, as long as you have two angles and one side. Okay, and we will move on and look at an example of how to use that in the next video.